Hello, everybody, and thank you for joining us this afternoon. My name is Paula Basili, and I am with the Center for Geospatial Solutions, which is one of the many organizations working to bring the Internet of Water vision to life. And I'm excited to be your moderator and host for today's webinar. So before we get started and hand things off to our speakers, just a few small housekeeping items. First of all questions are welcome at any time. We love questions, so please use the Q&A function down below to submit those at any point in the conversation. Our speakers are going to be waiting to address questions until the end of the presentation, just so they can focus on delivering their preview of the tool. But don't worry, if you submit a question, it will absolutely get answered. So please use that function. And then the second thing to note is that the webinar is being recorded, as all of our Internet of Water Coalition webinars are. It will be posted on our YouTube channel in just a few days, where you'll be able to revisit it and share it with your colleagues. So with that, I am excited to introduce our speakers for today. We will be introducing the Storm Events Database Explorer and are here joined by the team from the Commons, Earth Genome, as well as the Duke University Nicholas Institute, who helped bring this new tool to life. So with that, Brad, I think we're going to hand things over to you to get us started and dive right in.
Thank you very much, Paula. I will
Sure
get
thing.
my screen request sent over here. There we go. And sharing now. All
Perfect.
right.
Thank you.
Thank you. So thank you everybody for joining. We'll be talking about clearing barriers to storm data and getting to know the Storm Events Database Explorer from the Internet of Water. Quickly today, I'm going to start off with a brief agenda, just so everybody knows what we plan to go through. We'll have an introduction first to kind of set the stage for the project and what the need was. We'll talk then about the project approach and the steps that we took to actually build this out. We'll finish with a walkthrough of the live application, and then we'll close out there with some time for Q&A. And with that, I'll go ahead and pass it over to John Dawes, Executive Director and co-founder of the Commons.
Awesome. Thank you, Brad, and thank you, Paula. It's great to be with everybody today talking about the Storm Events database. So I guess, Brad, if you could go to the next slide just quickly. This project, we're really excited to have the launch of the Storm Events database and the Explorer application, which we'll be sharing today. It's really the culmination of some really exciting work that was predominantly tackled by Internet of Water Coalition and Duke University Nicholas School, the Commons, as well as Earth Genome. And this is a really exciting project, not just because of the outcome of deploying the Storm Events Data Explorer, but also the really impactful team that we were able to assemble together to really kind of bring this application to life. So just high-level background on the team. Internet of Water Coalition, as you know, really focuses on data integration through peer-to-peer networks and hubs, really kind of building incredible approach for fair data standards as it relates to water data. Our organization at the Commons, we were founded to support environmental movements with high quality access to open digital services and toolkits that can really lead to enhanced environmental outcomes for the greater good. And then Earth Genome works to really do some incredible work on the technical side, transforming environmental data into actionable insights with AI and user-centered design. So that's our respectful team for this project. And Brad, if you could go to the next slide there. In terms of these partnerships, everybody played like a really quintessential role to delivering the Storm Events Data Explorer. So in this case, Internet of Water and the Nicholas School really sort of served as that product owner. They have some, really solid partnerships with NOAA and specifically target users of this application, and we'll talk about that in a bit. But that was really kind of, I think, the secret sauce to making sure that we were able to stay on track and kind of apply our respective skill sets to delivering the application. Our team at the Commons supported this project, focusing on the user needs assessment and really kind of being a preliminary layer in developing a very high level specification for the work. So we were kind of in the weeds, working to understand the data model, what the storm events data, how it's structured and how it can be effectively used. And then our technical guns on the project was Earth Genome, who really brought a lot of the ideas and directions to life through some very robust user interface and user experience design and development work, and also providing the technical infrastructure, which was really critical. So we can go to the next slide. So a little bit about Storm Events database. So the Storm Events database was initially started by NOAA through NCEI. These data are leveraged to create basically an annual publication known as the NOAA Storm Event Publication. And as far as the attributes that are focused with this database, it's really targeted at being able to document severe weather impacts. So specifically loss, damage, and disruption to our nation's infrastructure. And there's quite a significant amount of coverage there. The database also documents unusual events. So these would be things that don't happen too often. So things like snow in Florida, or even down to extreme records, such as high temperature and precipitation extremes. And if you go to the next slide, Brad, that'd be awesome. So yeah, so in total, the coverage of the database is pretty incredible. It's a total of 2 million, roughly almost 2 million events. I think we're at around 1.95 million events. And those events span from 1950 to present. The thing that's important to note and kind of a fun fact is that I believe the storm events database developed by NOAA started first with a tornado registry and has since expanded. The current setup, and I would say previous to our implementation of the Storm Events Database Explorer, which we developed, is that this was actually a very solid approach for open data. So through NOAA's website, if you go to the Storm Events Database website, you're able to see sort of the full lineage and set of data that is available. And NOAA makes these data public through an FTP site with yearly CSV downloads for each element of the database. And I guess, Brad, if you go to the next slide, there's yeah, so like this is an example of this respective interface. There's the ability to bulk download data again from that FTP site, and it was really solid in terms of access and providing data transparently. One of the big challenges, however, that we seek to address with the Storm Events Database Explorer was really to kind of put a front-end interface on that and make access and exploration of the data a little bit easier on users. So this project was really positioned to kind of stand on the shoulder of giants, if you will, with NOAA and the strong progress that they made, and then really make it a lot easier to access that information. And without going too far in the weeds, you all can kind of explore this NOAA site on your own and also the Storm Events Database Explorer. But what's important to note is that for utilization of these data, like local disaster mitigation planners, for example, most of the time they'd have to pull these resources and spreadsheets, kind of relate them on their own, and do a lot of sort of data sciencey exercises to get data wrangled into shape. And so with our application that we've deployed on top of this infrastructure, We've really tried to shorten the time and hopefully eventually cost in terms of being able to access these data quickly and immediately put them to work for planning purposes. And you can go to the next slide there. Yeah, and so this is just a quick screenshot of, again, the full data access that's available through NOAA's FTP site. So again, Storm Events Database Explorer, which you'll see here in a bit, effectively, pulls all of these data, structures them, and makes them very easily digested, easy to access and download and use for specific regions. And you can go to the next slide. And I think I'm turning it. Oh, yeah. And then, sorry, very last thing. In terms of the overview of the system, from the version and sort of how it's evolved, um, we've seen, a number of records sort of added throughout this time period. So you can kind of see the markings in terms of when new storm data was added and sort of the periods there. And so there are still some gaps, in this respective data, which we'll see pretty easily from the Storm Events Data Explorer. But this just gives you a sense of kind of the history, the web history there. Awesome. And so I will turn it back over to you, Brad.
All right. Thank you very much, John. So after that initial setup, describing the project, the existing project rather, I'll be diving into our approach to pick it up and go a little bit deeper on that. The process that we follow is a typical process that we go through on a lot of our projects. There's a discovery phase, which John and the rest of the IoW team did a good job starting on. We went a little bit deeper with some user research as well as some data deep diving. Then there was a prototyping stage, and we get in from there to design and development, leads into QA and testing and make sure everything actually works correctly, and then deploy it. And then lastly, we want to get the word out, which is, again, part of today. And thank you so much for being part of this webinar. As far as understanding user needs, we ran a user survey with 20 questions across user backgrounds, the current workflow. So we wanted to follow the user's pattern through the existing application and see what their pain points are, what are they trying to do, what, if they had a dream system, might it look like? And we surveyed across, we had some climatologists, we had some insurance analysis in there, and we also had even some real estate folks in there as well. So we really got a good gauge on, okay, what are some things that we want to try to address with this project? The next step was to dive deep into the data. So from what we could see from the outside would be NOAA's CSV files and a bit of documentation about it. We know there's a database behind the scenes there, but we really needed to understand the structure of it more. So that took a lot of work into seeing what tables exist, how might they be related, what individual fields exist in those tables, how there are gaps and missing data or duplicated names, those sorts of things to kind of understand what we might have to clean up. Also, looking at just the event types themselves, what data does this actually represent inside of the database, and how many of each of those event types are we talking about here? And then lastly, categorization. So something that the Storm Events database from NOAA didn't have was kind of chunking those individual events into groupings. And those, I think that's really one of the value adds that we ended up on in the scope of this project, was creating categorizations that grouped those event types together to make it much more simple to analyze certain categories versus others. Next was prototyping features. So we knew at this point from talking to our users roughly what we wanted to try to build. We looked at the data and said, okay, we think this is what we have to work with. And then we said, okay, what can we do with that? And that prototyping phase really brought us to looking at dots on a map. And after seeing how many dots there were on a map, falling into the red dot problem, we call it, of too many things on the map at once. So we wanted to explore aggregations and the density analysis so we could kind of see where everything was, and then also dynamically filtering that. So we had category filters. We also had those individual event filters. We have a temporal aspect here that we need. You can see that in the slider graphic here on the screen. And we needed all of this to work in what we call web time. So we know a second or less for all of these filters to be applied. So that was a neat problem that we got to go through in this prototyping stage to make things as fast as possible and see where those technical limitations were. Next, we had an idea of what was possible. Now we needed to know what we wanted it to actually look like to our end users. So this process goes through a series of different stages, which is a lot of brainstorming and then coming back together as a wider team and getting feedback and adjusting and going back and doing some different design iterations through different cycles. Also looking at inspiration in this stage, what else is out there? What visualizations do we like? What don't make sense here and what might make sense for us? Applying design systems and even getting into the details of a color palette. How do you choose a color palette that works correctly with the map and with this many breaks of categories, what makes sense to visualize everything with? Finally, after all of that, we came together on a final design iteration and got things pretty close where everybody was like, I think this will be what we want to make. And also considered things like responsive design. So this does work on a smaller screen device as well. Finally, development. So we take all of that design work and all of that planning and then actually start writing code, setting up servers, all the architecture and database work behind that to get everything pieced together. And then as part of that, once we're in this kind of development push stage, we move into the Q&A and the testing at the end to squash as many bugs as we can find and get everything working, in a very solid state. And then finally, after we publish that out and get the production site up, it's getting the word out. And so that's part of what we're doing here today. We also have, I have a few links on the screen here to the Internet of Water page that introduces the Storm Events Database Explorer, as well as a great blog post from the Commons that gets it's a case study that goes a little deeper into the project. And then just generally sharing it out on LinkedIn and those sorts of things. John and I were recently in Reston, Virginia at the Free and Open Source for Geospatial Conference, kind of giving an initial talk and some more technical details on the project as well. So that's the process, and this is what we ended up with. This is a static screenshot. We'll get into a walkthrough here in a second of the Storm Events Database Explorer, and I'll jump out of this screen now and give a little bit of a tour of the application really quickly. Here's the URL. Feel free to write this down, take a screenshot, take a photo of your screen if you need to. We'll have this available, and you can also find it on the Internet of Waters website as well. All right. So diving into the walkthrough here, I'm actually going to refresh this page just to show a nice little animation here at the beginning that scrolls up, and this is pulling live from the database. So as we make updates to this site going forward, this count will go up, and you'll be able to quickly see how many events are recorded in this database here. This is just a landing page that kind of shows that count, and then also has an about the data section, which I'll jump through first. This is available inside once you actually get inside of the application as well. Some highlights here, we have the data source. So we wanted to make sure that we pointed back to the original source because this project really ended up as a bit of a derived data set with some value add, like that categorization and some cleaning up of the data set as a whole. But we did want to point back to the original NOAA data set. So that's linked in here. And it talks a bit about the data set itself. So the coverage, about the tool. So some of the filters that we have for the time periods, the event categories, it's the specific event types, the geospatial filters, those sorts of things, as well as the API access. So I think that's another great addition to be talking about here with the project is that we have this application of the Database Explorer, but we also have an API that's mostly meant to support the application here, but is also accessible. So we made that available for people to use. And then in addition to that, if you need a bulk download, we actually pushed all of the data out of the API into Source Cooperative, which is part of the Radiant Earth Foundation and is an open data resource. So quickly here, I'll jump over. This is what the API looks like. We have some documentation that's available as well for anybody who is more technical. You can read through this and kind of see the capabilities. And the source cooperative page also has downloads of those bigger files for bulk downloads as well. The methodology, I'd encourage you to read through this if you're curious about those categorizations we mentioned earlier. Folks from the Duke School ended up going through and really thinking about this quite a bit. And we went back and forth and landed on a pretty good grouping. And this page describes what those categories are, also the event types that make up those categories, and then why we came to those groupings, as well as some use cases. So we thought pretty deeply about how a user would actually use all of these individual event types and which filters to toggle and why it would help you in that certain circumstance. So a lot of good details in here and resources to understand how to use the tool. And then there's a partner page there as well. All right. Now we'll actually go inside of the tool here. So if you click the big Start Exploring button, the application will load up, and you'll notice this looks quite a bit different than some of those screenshots that John shared earlier. We really took a different approach here because the data was not spatially presented previously, and we really thought that it had a lot of value in that aspect to be on a map, and so that's the direction that we went with it. Before I dive into actually changing filters and getting into the tool itself, I want to do a quick little tour around the screen. In the top left, nothing fancy, just a title. If you click on the title, it will reset the application. So if you have filters set, this will go ahead and clear those and refresh the entire site. You can get back to that About page. I mentioned that is available inside of the application as well by clicking that little yellow, and you're back here to the About page again. And the big thing in the middle is the map. On the left-hand side, we have our filter panel. So I'll change some of these here momentarily, but for right now, I just want to call out, we have year and date, so some temporal filters here that you can set at the top. Individual event filters that can be set. Filter by location, which would be states or territories. And then once you set a state or a territory, you can actually go one level deeper to counties or districts. And then below that, we have the impact filters. So property damage, crop damage, direct and indirect injuries, and direct and indirect deaths can also be set. If you toggle this on, that filter will get applied if you have a value in there. If you toggle it off, it will turn it back off. So you can combine these filters in different ways to really go through an analysis directly in your browser of the data set. Below that, and slightly connected to those filters here are the categories. So right now, all are selected, but you can select one or more combination of these category filters. And so that will grab all of those event types that have been rolled up to that category and apply that filter across the board to the data set. This also acts as a bit of a legend to the map. So the colors actually correlate to the colors on the map and the chart. So the categories are the variants in color that you see here. Below that, we have our stacked bar chart, which is showing the count of and the distribution over time of all of the data in the data set that's been filtered. So this will also react to any filters that get applied. In the bottom right, we have the impact panel. So this shows the total event count. So as you're filtering, that event count will change. And then it also shows the total cost, injuries, and deaths combined. And those all, again, react to any filters that are changed on the map. Above that, in the top right, we have a search. So if you want to type any city name, we can go ahead and zoom you to that area. It's just a quick way to get around the tool. We also have a table view. So the toggle up here in the top right. Also, sometimes people don't need a map, and we understand that. And so you are able to actually switch back to a table view. This is showing all of the data in the data set, so nearly 2 million. And so as you scroll, it will just keep scrolling for 2 million. As you filter things down, this will get shorter. So it's really useful. And also I'll show selections in a bit. So that selected data can also be seen in the table as well to kind of filter things down a bit. The table also shows more columns. than the actual like click event on the individual points, which I'll get to in a bit as well. You can also share in here. So that's something we wanted to make sure that this was able to be easily shared around with the applied filters. So any filters that get applied also show up here as URL parameters. So that can actually be copied really easily here and then shared with someone else. And the application, when that URL is loaded, will set all of those filters, zoom to where the map was last, and those sorts of things. And then lastly, on the little tour around the screen here, we have our download options. So there's two download options that we support. Filtered events, so any filters that get applied. We have a maximum here because these are custom filters, so that equals a custom download that has to be created. But we do allow up to 10,000 with the infrastructure that we have in place here behind the scenes. So anything less than 10,000, you'll be able to download a custom set of data. Also the selected events. So if you select individual ones, which usually you can't quite select that many, so we allow that to be downloaded as well. Right now, nothing's selected, so it says that I can't download anything. And then just a callback at the bottom here, we do have those bulk downloads available if someone does need the full data set. All right, that takes us around the screen to see all of the different components. Now we'll start interacting with them a little bit more to finish out the walkthrough here. First, I want to talk about the map. So we did a lot of work cartographically to decide what we wanted to show and how we wanted to show it. I talked about earlier having too many points to show on the map. One, there's a technical challenge of showing so many points. But really, it's about the user at the end. To showing so many little points on the map actually give them value. And what we decided on is actually at this zoom level, showing an aggregation. So what you're seeing here are dots that are gridded, and each of those dots represent a lot of points that are in that area. So it's really a coverage map to show density and also type of event. So you see two things here on your screen. You see color, which I'll click on one of these as purple, and you also see darker purple and then some lighter purple. And once I click on one of these dots, this dot grid, you can see why we're seeing these colors here. So I see the total events underneath this dot are 3,000, but we also break them out by how many events are in each category underneath that dot. So we see we have the most here would be storm, which is purple, and we have 1,200 of those. If I click on a lighter purple one, we'll see we only have 47. So that's just a difference in the total count, and that correlates with the color gradient. And then the color itself, if I choose one that's not purple, we'll see here one that's wind. So there's more wind events in the category than any other event type, and so that's the color that gets applied. And so that's the symbology that we ended up on with the map itself. And this will adjust. So as I set a few filters here, I'll toggle on heat. We'll see heat gets applied across the map. We see our chart got updated. The entire map got updated as well. You can combine these filters too. So I'll choose tropical, and we'll see some tropical down there along the coastline. I'll turn on winter weather, and all of these will be added and aggregated up again dynamically on the fly. And so now we see what we might expect here. There's more winter weather happening up north, and we see more heat events recorded down south, and we see the tropical along the coastline. So these can be combined in different ways to visualize different patterns, both in the table, in the chart, as well as on the map. And especially if you turn these off, you'll start to see only one at a time. Tropical is a great example of that. It's exactly where you might expect to see a tropical pattern forming. Really quickly, I'll talk about the temporal aspect of the chart. So you see some jumping around here in the chart. And so this is something that John talked about earlier on, is the data change over time. So in this data set, we had early on where only tornadoes were recorded, and then it expanded a bit more. And then in the 90s, it expanded to a whole bunch of different categories. And so that's part of the reason that you see this drastic change in the distribution around 1995. we wanted to make sure that we called that out. So we have a little note, a callback to that. One, it talks about, points you back to the storm database itself, but then we have a little detail panel about that too. So if I change my time here to be up into the 2000s, you'll see that we see a much more consistent data pattern showing up. All right, so going through these filters, I started on a few of them here. As you change the temporal filter, you'll see the data on the map, as well as the chart and the summary panel update here. So we're seeing the number of events from 2003 to 2014. All of our chart updated as well. You can hover over that for each stacked bar and see a count and a total. And then our cost, injuries, and deaths also update as you change that time aspect. If you go to 10 years or less, you can actually change this chart at the bottom here to see a month view. And so this really is interesting to see different patterns. So you can kind of jump between winter and heat and kind of see seasonality. You can explore other patterns on a month-to-month basis as well, which is really useful. I'll go back to all and the full year. And if you come down to a single year here, I'll go to 2003. You have the months, but you also have the individual days. So you can, if you wanted to dial in even deeper, you can go to individual days for a single year, or you can even go to 6 months or shorter periods of times with this other date range filter there. For right now, I'll go ahead and reset the be everything here for us. The next filter I wanted to highlight is the event types. So you can choose any event type or combination of event types in here. These are grouped by their categories as well. So you'll see the color here also correlates to the category. Debris flow is one that I like to click on because it's pretty neat to see the pattern. It's where you expect in the mountainous areas to be around the US. These can be combined also with the filters. So if I want debris flow, which is part of the flooding category, but also all of heat, you can toggle that on and that will apply all of heat plus the debris flow on its own. So they can be combined in really interesting ways to see patterns. I'll go ahead and clear that one off for now. And I'll put on one of the filter by location filters. And these can all be combined in different ways. I just want to show them one by one to make them very clear here. So here we're seeing all of the data aggregated to the dot grid over all of Arizona. Again, all of these other filters work. So you can toggle to winter weather, for example, and get, we see there's not too many events there, especially things like tropical. That probably might be one. Yep, grabs one there, but not that many. You can also go deeper. So once you have something like Arizona selected, you can go down to the county level. So if I choose one of those counties, everything gets filtered down even further based on that. So we only see 232 events at that point. Only 2 injuries and 4 deaths. And from here, you can filter that down the years even further to make that more refined to actually get the data that you're looking for out. While I have some of these filters set, I wanted to go ahead and jump over to the table view. So this is what we showed earlier, but you'll notice it doesn't scroll forever and ever anymore. And that's because the table is being filtered just like our map data set. So there's only 42 records now in the table. And if you go to the download page now, you'll see we are able to download our filtered events now because we only have 42 events. You can click download the CSV and you'll be able to open that up here. And there we have our 42 events available just like that out of the data set. I'll clear a few more of these off and go back to the map here. One other thing I wanted to share was the sharing here. So I'll go ahead and copy that with the filters that are applied and open that URL in a new tab, and we'll see everything resets to back where we were. And so it's easy to share out any filtering in any zoom level that you're kind of at inside of the application. Property damage, again, once you toggle that on, you can start adding numbers in here. So I'll say property damage in Arizona, it's greater than 500. So we see we're down to about 1,100 events. Maybe we'll say less than 10,000. And so that'll get that range even tighter, so 782. Maybe we'll say less than 1,000. And we see we're down to 300. So you can really play with these filters and quickly and dynamically visualize the data set and also be able to download parts of the data set as needed. And you can just apply one of these. So if you don't add an upper limit, we'll say greater than, we'll say 5,000, we're down to 600 in some records, 50,000. Let's see if there's anything at 500,000. There's still 44 events there. Go 5 million. Oh, there's 11 events. So you can really dial this down to exactly what you want to get out of the data set. And that same behavior applies for all of these additional filters for the injuries, the deaths, and the crop damage as well. I'll clear that one off there and come back to here. And last thing I want to show is once you zoom in. So I'll go here to jump to the Washington, D.C. area quickly. And now what you'll notice here is this looks a bit different than those original dots that we were seeing on the map. So I'll zoom out just a bit just to get back to that. And you'll notice again, we're here with our dot aggregation. So you can see those bigger patterns and see where we might want to zoom in to a specific area. But as we zoom in, things are getting adjusted and again, dynamically adjusted. So we start to see, once we get to a certain point, all of the individual events. So once you see these markers on the map, that means these are individual events, and you can actually click on them to get more data. I can also recognize there's a lot of data on this map still, and we worked really closely to get that line correct. So if I were to change to something like just flooding, we're actually going to start to see that sometimes this really makes sense. Once I turn back on everything, it starts to get a little fuzzy again, but some of those filter combinations make that threshold kind of difficult to choose. So what we ended up doing is allowing users to show a lot of features at this level and just saying, hey, you probably want to zoom in here with this little message to make sure that you can easily visualize what you're trying to see there. We'll come back over here to DC. And again, as you filter through these, the map will update. You can also click on them. Before I click on them, I want to point out we see some kind of gold colored icons here with a number inside of them. And those represent, if you're familiar with geospatial applications, lots of times we talk about clustering. So that's when several points are close together and we kind of group them together underneath a different symbol to say there's 5 in this area. That's close to what's happening in this application, but what those actually represent are stacked points. And so in the data set, we found that there's actually some points that are recorded at the exact same coordinate. So we can end up with a point that sits on top of a point. And so that's really difficult to visualize. And we tried a bunch of different solutions. And what we ended up here was with a stacked point and a count. This again will adjust dynamically as you change your filters. And it's also clickable. So like an individual event, if you hover over one, it says there's 5 events recorded at this location. You can click on that. First, I'm going to click on an individual point. You'll see that gets highlighted and centered in the map, and it shows an event detail panel here. So here we have our event type, the event ID or the episode ID if you really wanted to know those things and search through the database more, the location and its coordinates if they exist, our time, other details like the category, the weather office, the source that reported that storm event into the database. If there's impacts, those values would show up here for this individual event, as well as the event narrative is shown at the bottom there. There's also in this data set the concept of episodes, which is generally just a grouping of events that are related. So we wanted to make sure that we could represent that parent relationship in certain ways to all of those individual events. So you can click on an individual event and then also jump to the full episode. So here I clicked on one and we see there's 34 events. This shows the full episode narrative that is distinct from the individual event narratives. You can see how many there are inside of that. You can click a zoom to button to kind of see the distribution of those events spatially. And then you also could click on any one of these events in this list to jump back into that detail for that specific event. If you click on one that has multiple points, so here there's one that's 3 that are stacked points that I talked about, you'll see that multiple events are selected and you can page through them. So you can jump between each one. Some of these don't have a parent episode. So this one doesn't show that there's any parent episode, but the next one over does. So you can go through and click on that one and explore that episode too if you'd like. Some of these you'll notice have a lot of events recorded at a single location. And that can be for a couple different reasons. One, there could be exact coordinates recorded multiple times, or coordinates that were truncated in the original data set, so they appear to be exactly in the same location. Or there were points in the data set that actually had no coordinates recorded. And because this was a spatial application, we needed to represent those some way because we had conversations and we didn't want to completely ignore them. And so what we ended up doing was moving them to the centroid of the nearest geographic unit. So that could be a county, that could be a territory, or any other area that made sense to actually move the point and to the center of that area and drop a real point on the map for that one. But we notate that in the description so you can be aware of that. And then, right, we have quite a lot of points under this one, and you'll see this one actually spans multiple categories. So we see here air quality, and the colors change, the location that's selected, as well as the event detail here. And you can jump through each of those and see what you're trying to see inside of that particular item. Once I have some selected, so I'll select these three here, I can come back to my table view, and I see I have 3 events selected. I'll come back to my download to only download those 3 events. And here we'll click download that CSV, and that should open us a very small, yep, only those 3 downloaded out of the data set. If you wanted to come back to all of the events, you could jump back and forth once you have something selected inside of that. All right, I believe that concludes the walkthrough. Anybody else on the panel, feel free to let me know if there's anything else that we want to jump through here at the end. But I think at this point, we are ready to jump over to a Q&A. Paula?
Awesome. Thank you so much, Brad and John, for that walkthrough. Wow, this is a really beautiful front end interface with a lot of functionality built in. So it's really exciting to see all of the many different ways that you can explore the data. And we've got some great questions lined up from our attendees. So thanks everybody for jumping into that Q&A function. And again, if you have a question, that's definitely the place to drop it. So I will say one of the first questions we actually got was a little bit around definition of a storm. And I know with all data, definition is really important. And so, for example, Cajun James notes that in California, state databases typically define a storm as no precipitation for 72 hours followed by precipitation. Can you speak at all to kind of that determination definition of what makes a storm and how that might vary on the federal level versus kind of state and others?
Yeah, I can chime in a little bit, and I might also ask Lily for some help as well. So in terms of the definitions specific to the storm events database, um, basically the storm events database as it relates to NOAA, they're effectively defining storms, kind of in a broad way. So according to like the NWS documentation 10-1605. Basically, a storm event is, classified as, a bunch of little sub events and episodes that really have individual types of storm phenomena like thunderstorm, wind, hail, tornado. So it's a much, I think, broader definition that can encompass a variety of uh, systems that are occurring within an event. So things like traditional storms, winter storm, ice storm, these are sort of like the recognized examples of recognized event types that are part of that NWS directive 10-1605. And so I will, fully defer to Lily or anyone else who kind of wants to add additional information. But that's sort of the classification approach that we've taken, and again, just followed that NOAA guidance as directly as possible to make sure that the data is exactly reflected as NOAA specifies.
Yeah, I'll just say what John said is exactly correct. And then as far as those broader categories that you see as at the bottom of the app, we created those as a group to make the data a little more easy to understand and interact with. And we did that both with the consultations with the climatologist on our team as well as someone at NOAA. And we kind of experimented with several different ways to group those categories. But there's some more description of that within the app's About page of how we kind of came to that grouping. Of course, you can go in and separate out the individual event types as well.
Awesome. Thank you. That's really helpful. Yeah, it's with this information is used by so many, right? For so many sources that it'd be even hard to think about encompassing all of those definitions, but it's really helpful to see how you guys made sure that you were very clear about how NOAA guidance was really showing up throughout the tool. So that's really great. And kind of along that same line of thinking about the source of the data itself. Esther asks, how is the number of reported events checked against or generated from sensor data? In other words, is there a way to kind of understand and see what the data source is, whether that was from a human report or from a station identifier, for example?
I guess I can help field this one. So that really depends on the event type, but we do expose an attribute from the source data set called source, actually. And so that would tell you who reported the event. And that could be anything like a train spotter, a 911 call center. It could be a stream gauge in the event of a flood. So again, it really depends on the event type, but that data is there. But it's going to depend again on what sort of event was recorded.
Yeah, makes sense. And I think one of the other really interesting things about this tool is that it is both, you were presenting it in kind of the desktop version, but I think I heard you mention that it is also available on mobile. And so we do have another question specifically asking for any reflections on lessons learned for displaying such complex data in mobile devices in general, or even more specifically, in an ADA compliant way.
I do have a response for that, and I might share my screen one more time quickly
Go for it.
to go ahead and pop this out and adjust the size here. So that's a very challenging problem, and it always is. So here you can see the representation of the screen in the mobile view. Let's see, is my screen sharing? Double
Your
checking,
screen is
Paula.
sharing, yes. Yeah,
Perfect, thank you. All right, so you can see it in the smaller view here. So everything, we tried to pack in as much functionality. Some tables, basically all tables, never work well on a mobile device. If you try to open a giant Excel, right, it doesn't really work. But it is there if you wanted to use it. As far as the buttons, it's really just orientation and positioning and a lot of thoughtful design work. Speaking of the ADA and accessibility requirements, so that's something that we have a follow-on to go another pass through. So we passed it through one additional designer that brought up some of those concerns. We actually ended up with 3 different designers consulting over different periods on this project. And as far as the accessibility requirements for the colors, that's one of the most difficult things here. So we have some where we added the icon on the legend itself, but that icon doesn't exist on the map. So especially when we consider color blindness and that sort of user inside of the application, there's tools that we can use to pass the application through to check for accessibility requirements and see what we might need to change. And so we have plans in the future to make sure that we can address that as much as we can. And one thing with us being downstream from a federal entity, there's no explicit requirements, but we want to always do our best, right, to do as much of that as we can. So we thought about as much as we can, and we didn't quite get there by the release, but we have future plans to make sure that we address as much as we can there. But it's a difficult problem in general, yeah.
Yeah, definitely. And kind of speaking about the continued evolution, kind of maintenance of the tool. I'm wondering, we have another question around, how this data set will continue to be supported, given federal cutbacks. I think there's both, that question can be thinking about both, the data set itself at NOAA, but also about a tool like this and kind of where it heads from here, especially since we know uh, there's always improvements to be made. So I'm wondering if we could maybe address that as well.
Yeah, I can hit this on a high level, and we'll also defer to Brad and Quinn on this as well. I think in terms of the future of the project, and especially like I looked at the Q&A about, funding cuts as well. It's a really important time to really make sure that these federal data sets sort of live on no matter what, right? And so I think one of the things that is really exciting about this project is that we're effectively pulling down and restructuring data for use in the application, which means that we have, essentially a version that is in lockstep with NOAA. And so, worst case scenario, if funding or support for that data would pause or go away, we do have that sort of archived and structured. That has also been done through some really great work through Source Collaborative, that has really kind of helped us host that data as well. And then in terms of kind of future development on the project, this is something that, the Commons were continually identifying places to resource, future updates and enhancements. So that's an area that we're, kind of constantly on the hunt for. But I can also turn it to Brad and Quinn if you all have anything else to add there.
Yeah, just in terms of like assuming that you know, funding would continue for I mean, we all hope that it does. As long as that's the case, we intend to update or rather sync the Storm Events Database Explorer with NOAA's source data every month. Typically, they've been updating the data sort of once a month, and that's meant to keep the data set up to date, sort of as of 3 months ago. Right now, I think that the latest events are from the end of May of this year. So they haven't quite kept it up to date, but that we just got done with a big shutdown. So we're hoping that they'll resume updating it every month pretty soon.
Also, I have one other just quick idea and thought to add on that, which is like, in terms of the sort of structuring, I think the service that, could potentially lead to a really good partnership with the federal government is that this is a really, and I know I'm biased because I've worked on the project, but I think it's a really good model for sort of how to take government data just from the next step of discoverability. Like there are a lot of challenges to overcome just on the development side. And so like the more that, this type of team composition and work can be applied in a meaningful way to kind of help, say like, look, we've gotten really far with open data, made it accessible. Adding sort of these like data access and exploration layers on top, I think it's a really good value add and could lead to really good part like federal or cross-domain partnerships.
Yeah, definitely. A couple of questions just about the tool itself and kind of features. Well, two questions I think specifically. One, if we jump back into the tool, wondering, if you do identify or select an event in the table view, is there a way to find that easily again in the map view and kind of toggle between those two? And then second, too, curious if there's the ability to filter by HUC, by watershed, right? We've got a lot of water professionals on the line. It is the Internet of Water after all. And so we're frequently thinking about HUCs, HUC 4s, HUC 8s. And so curious if that's been built into this initial this kind of inaugural version.
As far as the interactivity between the table and the map view, I can answer that one. The answer is no. Currently, if you try to select something in the table is not able to be selected. It's a view-only table that can then be exported. So the interaction and the click events on the map is the main way that you'd select an individual event.
In terms of and filtering by watersheds, that's not built in yet. That one, again, it depends on the event type. I'll just keep saying that, because certain types of events, which you probably wouldn't want to look at in relation to Huck 4s or 8s anyway, they might be mapped to just a county or a forecast zone, and they might not have, a single point that identified as where that event happened. You could think of like a heat wave, for example. That's one of the event types in here. But for flooding events, I think they typically have assigned them specific point locations. So, in theory, that's possible that we could add Huck filtering just with those caveats in mind. So that could be worth exploring for us.
Yeah, very cool. And kind of along that question of, asking, how this tool comes together, there's a question a little bit around the tech stack, right? So like what platform is the app actually built on?
Yeah, I'll take that for Brad and I. So we're not using, things like Power BI or Tableau. This is built on, one, the API is built using Go, which is a common programming language. And the infrastructure is hosted on Amazon Web Services, which is a pretty common choice for applications such as this. And then the front end, it's all custom Next.js, hosted in Vercel. So we really wanted to make this shine, and that meant sort of using the state of the art in terms of software development.
Very cool. And so a couple of questions, because I know you all mentioned there was, that there was a very long and thorough kind of like design process that you all went to. And there's some questions in the chat that kind of start to get at these questions of, okay, how are we actually presenting the data? Ginger Davis has a good one about, the possibility of turning non-point features into other data styles, right? So for example, lines for tornadoes or polygons for floods and others. And so curious to kind of understand how the team maybe considered that approach or would be thinking about considering something like that in the future, as well as the idea of using time series heat maps, right? So there's a couple of different techniques that I think you can use for this type of visualization. So it would be great to hear a little bit more about that.
So I can speak a little bit to the heat map and the change in data over time. So I think that doing something like that is challenging in the context of the dynamic filtering that we talked about. So that's something that recently, when John and I gave a more technical talk on this at a conference, that's something somebody asked. And those dynamic filters and visualizing that on a map and combining all of those filters, you can't like do caching at that level because it's too many combination of all the different filters. So I think it's certainly interesting to be able to do a time series heat map, but I think that's maybe better served by using the API or somewhere else in a Jupyter environment or something like that, where you could do a little more custom for your specific need to visualize that. And instead of this more generalized tool, to understand those patterns. And I guess quickly, I'll hit on the turning non-point features into other data styles. So lines for tornadoes, polygons for floods, or bounding polygon for drought. Quinn can probably also speak to the complexities of this data set and understanding lines and points. And there's a starting point and an ending point recorded sometimes, which represent really like the width of the event via just 2 points. And so it's a really interesting data set to play with. But there certainly are limitations in trying to just visualize the data set as it is. There's expansions you could consider, but I think it's more combining extra data sets rather than just purely deriving things out of the data sets as they exist right now.
Nice. Thank you, Brad. And then the last question, kind of as we wrap up, another one from Esther here. AI is the big buzzword, isn't it? And so have you considered maybe how to expose the data to AI, or whether using the API, and whether AI could be used as an improved filter, or just kind of any other maybe just ideas or brainstorms that you all may have had in putting this tool together? Um, and separately, I guess, like if folks are interested in using the API, I know you mentioned this was, kind of secondary. The API itself is made specifically for this tool, but if they are curious about how to kind of apply it to maybe some of their work, where should they go?
I can definitely like handle just at a high level, like the first part on the AI question. I guess we've actually had just since release a handful of folks reach out to us about potentially leveraging the data for some of their AI-driven storm event modeling to do risk assessment and sort of automating some of those pieces. Again, I think by making these data more readily available through APIs and through Source Cooperative, it's a really exciting point because basically those data can really kind of fuel an AI pipeline or predictive models, maybe more sort of in the machine learning category. So those are some definite use cases that I could see in the future that this data product could effectively be helpful for. And then the last really quick item in terms of like sort of feature ideas. I mean, like, yeah, it's definitely like a dream to kind of think about, having some like, chat robot, right, that could help you like understand what's going on. I think that's definitely a point of exploration that's worth kind of looking into, and something that might be worth considering down the road.
Yeah, and structured data is key for that, for sure. Awesome. Well, thank you everybody so much for joining us. A big round of applause and a thank you to our speakers, John, Brad, Quinn, and Lily. Thank you so much for joining us, and big kudos for putting this great resource together. And a big thank you to everybody who was able to join us for today's presentation. If you like what you saw, the Internet of Water Coalition is very frequently showcasing different tools that are really trying to promote data discoverability, water data discoverability, and interoperability. So if you have a suggestion for a topic, or a tool that you're working or a project that you're working on yourself and would love to spotlight, do reach out. And in the meanwhile, make sure to follow us on LinkedIn as well as through the IoW newsletter, which is a great way to stay in touch on all the great work happening out in the field. So once again, just wanted to say a big thank you to everybody. Really, really appreciate your time and hope everybody has a good night, and we'll see you next time.